Hello friends, my name is Manoj Chaudhary and welcome to today's session on Trigonometry 2 where we will cover few examples on double angle formulae. So here it is an entire list of double angle formulas for you. So please revise it once. The first formula for sine 2 theta is 2 sine theta cos theta. Then the second formula for sine 2 theta is in terms of tan. If you observe, the sine 2 theta is 2 tan theta upon 1 plus tan square theta. So there are only two formulas for the sine 2 theta. The first one is sine 2 theta is 2 sine theta cos theta, and second one is 2 tan theta upon 1 plus tan square theta. But if you observe, in case of cos 2 theta, you will observe total 4 formulas. The first one is cos 2 theta is cos square theta minus sine square theta, which is in the form of cos and sine. The second formula is only in the form of cos, which is 2 cos square theta minus 1. The third formula is only in the form of sine, that is 1 minus 2 sine square theta. And the last formula number 4 for the cos 2 theta is 1 minus tan square theta upon 1 plus tan square theta. So try to observe these formulas. So we already discussed the proofs of all these formulas in my previous video. This is just a simple revision for this formula. And if you observe, these two are the very special formulas which are derived from this result. So cos 2 theta is 2 cos square theta minus. So if you shift this minus 1 on LHS, you will get this very important result. So please remember this very important formula. 1 plus cos 2 theta is 2 cos square theta. And if you observe this next formula for cos 2 theta, which was 1 minus 2 sine square theta, if you make some changes in this formula, you will get this very important result. 1 minus cos 2 theta is 2 sine square theta. So I hope every one of you know these formulas. These two structures are very important one. So 1 plus cos 2 theta is 2 cos square theta, and 1 minus cos 2 theta is 2 sine square theta. So as far as cos 2 theta is concerned, there are 4 structures that you have to remember. The first one is cos 2 theta is cos square theta minus sine square theta. Cos 2 theta is 2 cos square theta minus 1. Cos 2 theta is 1 minus 2 sine square theta, and the last one is in the form of tan, which is 1 minus tan square theta upon 1 plus tan square theta. And don't forget these two very important results. 1 plus cos 2 theta is 2 cos square theta, and 1 minus cos 2 theta is 2 sine square theta. As far as tan 2 theta is concerned, we have only one formula, and please observe this very carefully. This tan 2 theta is 2 tan theta upon 1 minus tan square theta. So this is the entire list of double angle formulas. So this one was a short revision, but today's job is to face few examples on this one. So let's start with the first one. Is you have to prove that 1 minus cos 2 theta divided by 1 plus cos 2 theta, its final outcome is tan square theta. This is the thing that you have to prove. So let's start with the left hand side, and on the left hand side I am going to use this very important formula that we already discussed. The first one is 1 minus cos 2 theta. So friends, please observe this formula. 1 minus cos 2 theta is 2 sine square theta, and 1 plus cos 2 theta is 2 cos square theta. So if you remember, these two are the very important results that we discussed over here. So please apply these two formulas on LHS. So for this 1 minus cos 2 theta, I am substituting this as 2 sine square theta, and I am replacing this 1 plus cos 2 theta as 2 cos square theta. So in the next step, if you observe, this 2 and 2 cancels out, and you know that sine theta divided by cos theta is tan theta. So sine theta by cos theta is tan theta, but it is in the form of square. So sine square theta by cos square theta is tan square theta, which is equal to RHS. So we can mention this as, so let's mention this as equal to RHS. This one was I think very simple problem, just simply based on simple two double angle formulas. Okay, the next one in the list is, once again we have to prove the sine of 2 theta divided by 1 minus cos 2 theta is cot theta. This is the thing that we have to prove. So how to prove this thing? So let's start with the left hand side again, and you will observe once again these two double angle formulas. The first one is sine 2 theta. So friends, what is the formula for sine 2 theta? Formula is 2 sine theta cos theta. So if you remember, and we have a direct formula for 1 minus cos 2 theta, which is 2 sine square theta. It is all about recalling the double angle formulas. So right, these questions are very simple. So formula for sine 2 theta is 2 sine theta cos theta divided by formula for 1 minus cos 2 theta is 2 sine square theta. Okay, in the next step, this 2 and 2 cancels, but if you observe, one sine from the numerator and one sine from the denominator also cancels. So what is left? Then cos theta in the numerator, right? And since one sine from the numerator and denominator cancels, what is left in the denominator is a one more sine. So right, and we know that cos theta divided by sine theta is cot theta, and you will observe this is equal to RHS. So finally here we got LHS equal to RHS. So right, so here I started with very simple examples. So one more for you. So example number 3. So let's say the next problem is, what you have to prove here is tan x plus cot x is equal to twice of cosec x. This is the thing that you have to prove. Tan x plus cot x equal to twice of cosec x. So let's start with the left hand side. So friends, the left hand side is tan x plus cot x. But we know that tan x is sin x divided by cos x, and cot x is cos x divided by sin x. So right, okay, then your next job is to cross multiply these things. Means cross multiply this sin x with this sin x leads to sin square x, plus then please multiply this cos x over here. So this becomes cos square x. This is entirely divided by, now the multiplication of these two means sin x into cos x. So please observe this thing carefully. And we have this very important formula, sin square theta plus cos square theta is 1. So we know that the sin square theta plus cos square theta is always equal to 1. And if you observe, this formula is almost like this one, only thing is instead of theta over here it is x. So sin square x plus cos square x is 1. So right, so here I am mentioning the sin square x plus cos square x is 1 divided by, in the denominator, this is sin x into cos x, right? Okay, so but if you observe, this right hand side is twice of cosec x, then your job is to convert this somewhere. It's not a cosec x, so let me correct this thing. It's a cosec 2x. It was a mistake from my end, so friends, please correct it. So here I am correcting this RHS. So please observe this RHS. RHS is cosec 2x. So please correct it. I am requesting you. Okay, how to achieve that cosec x? So do one thing, simply multiply this structure by 2 and divide by 2. Why? The reason is quite simple. We have a very interesting formula, 2 sine theta cos theta. So right, so 2 sine theta cos theta is sine 2 theta, which is a double angle formula. So here I am using this 2 sine x cos, this 1 into 2. So this 1 into 2 is 2 divided by, now this 2 sin x cos x, you can mention it as sine of 2x. So right, further this 2 I am keeping as it is. Let's write down this sine of 2x aside, and you know that sine is a reciprocal of cosec. So if you remember, sine is a reciprocal of cosec. So this is twice of this 1 by sine is cosec. And if you observe, this is equal to RHS, right? Okay, so sorry for that. So let's continue with this very interesting problems on the double angle formulas. So next one is, what you have to prove here is, if it is a sine of 2 theta into tan theta plus cot theta, you have to prove that this overall structure is equal to 2. It's almost a similar type of problem. So let's try to simplify it. So here I am starting with the left hand side, and let's apply a formula for sine 2 theta first. Sine 2 theta is 2 sine theta into cos theta. Then formula for tan theta I am applying as sine theta upon cos theta. You can express tan theta as sine theta by cos theta. So right, then let's express this cot theta as cos theta divided by sine theta. Okay, further this is 2 sine theta cos theta. I am cross multiplying this structure again. So sine theta into sine theta is sine square theta. Then cos theta into cos theta is cos square theta, and this is simple cross multiplication. So over here in the denominator it is sine theta into cos theta. This is what happening inside a bracket. Okay, and if you observe further, this sine theta get cancels with this one, this cos theta cancels to this cos theta. I am keeping this 2 as it is, but you know that this very important identity, sine square theta plus cos square theta is 1. So right, so sine square theta plus cos square theta is 1. This is equal to 2 and is equal to the right hand side of the problem. So right, if you observe, the right hand side of the problem was equal to 2. So once again, this one was also a very simple example. So right, okay, so let's start with one more. The next example is, let's try to simplify. I am taking one very interesting problem for you people. So please observe this thing carefully. So let's say it's a under root 2 plus, let me write down in proper way. So let's say it's a under root 2 plus, then there is a one more under root 2 plus twice of cos 4x. So right, and here I am ending this first square root, and then I am closing this second square root. So right, you have to simplify this structure, let's say. So friends, our job is to simplify this structure. Okay, so how to simplify this one? It's very simple. So this is 2 plus, keeping the second square root as it is. If you observe, this 2 is common inside this square root. It becomes 1 plus cos of 4x. So right, it's a 1 plus cos of 4x. Okay, then the real task is to simplify this thing, 1 plus cos of 4x. For that, you have to use this very upbeat formula. 1 plus cos 2 theta is 2 cos square theta. If you remember, this is the important formula. 1 plus cos 2 theta is 2 cos square theta. See, if you observe here, this angle is 2 theta, but on the right hand side it is become half. So observe this, this is 2 theta, but on the right hand side it is half. So what if it is 4 theta? So on the right hand side it will be half. Half of the 4 means 2, so it's a 2 theta. So try to understand this very important thing. So whatever is the angle over here on LHS, it becomes half on RHS. So this is 4 theta on RHS, it becomes 2 theta. So our structure is almost like 1 plus cos of 4 theta. So let's simplify it, keeping the first square root as it is. Even I am keeping the second square root as it is. So friends, what is 1 plus cos 4x as per this formula? So 1 plus cos 4x is 2 cos square 2x. Please observe this thing carefully. Close the first square root, even close the second square root. Okay, so further, this is under root 2 plus, this 2 into 2 becomes 4, and this is cos square 2x. This is very interesting problem and very important for the objective kind of examination. So this is under root 2 plus, let's remove the square root because 4, square root of 4 is 2, and the square of a cos square, the square and square root cancels over here. If you observe, this is a square and this is a square root, and square root cancel. So what is left is cos 2x over here. Okay, in the next step, if you observe, this 2 is common. So let's take that 2 outside. So here I am taking this 2 outside. From the square root, it becomes 1 plus cos of 2x, which is also a standard formula. So here I am mentioning this standard formula. 1 plus cos 2 theta is 2 cos square theta. This is something that you have to remember, very important formula. So 1 plus cos 2 theta is 2 cos square theta. So this is under root 2. I am applying a formula for 1 plus cos of 2x. So let's apply formula for 1 plus cos of 2x. So this is 2, and 1 plus cos of 2x becomes 2 cos square x as per this formula. So it's a 2 cos square x. Overall, at the end, it is a 4 cos square x. See the simplification. Now the square root of 4 is 2, and the square and square root cancels for this cos. So what is left is cos x. So that's all. At the end, this is the end simplification for this very interesting question. So right, if you observe, this one was the original question. Don't get confused with the square root and try to apply this very important formula. This is very important one. So to simplify this question, this one was the main formula that everyone has to implement. So right, okay, so if you want, you can solve a similar problem where I am giving you a one more extra square root. So this is under root 2. So those who are interested, they can solve this one more problem. 2 plus 1 more 2 plus twice of cos of 8x. Close the first square root, then I'm closing the second square root, and then this last one. Okay, this is the question. It's exactly similar. Only thing is I added one more layer of the square root. So this is for your homework. I hope every one of you can easily simplify the structure, which was exactly similar to the previous one. So let me cover the next one, and very interesting question where we have to prove that it's a 16 times sine theta cos theta into cos of 2 theta into cos of 4 theta into cos of 8 theta, and you have to prove that this is equal to sine of 16 theta. This is the thing that you have to prove. Very interesting problem. You have to prove this is equal to sine of 16. So friends, here I am starting with the left hand side and splitting the 16 as 8 into 2 and keeping rest of the problem as it is. So that is sine theta cos theta, then cos 2 theta, then cos of 4 theta, and the last one is cos of 8 theta. So don't get confused. Don't measure the length of the question. This is very easy problem. Your observations are very important here. So if you observe this structure, 2 sine theta cos theta. So friends, actually this is a formula for sine 2 theta. Am I correct? So this entire 2 sine theta cos theta, you can replace it as sine of 2 theta. So right, so this 2 sine theta cos theta is sine of 2 theta. The rest of the things as it is. So this entire thing I am keeping as it is. The rest of the thing is cos 2 theta, cos 4 theta, and cos 8 theta. Okay, in next step, let's split this 8 as 4 into 2. So right, and let's keep the rest of the thing as it is, as sine 2 theta, cos 2 theta, then cos 4 theta, then cos 8 theta. Okay, then it's all about observing the things, friends. So let's observe this next thing. This is 2 sine 2 theta cos 2 theta. Now this is very interesting part of this problem now. So please observe the original formula and the thing that you have to apply over here. So please observe the original formula is sine of 2 theta is 2 sine theta cos theta. So right, this is the main formula. 2 sine theta cos theta is sine 2 theta. And if you observe, this is the 2 theta, but if you observe on the right hand side, it is half. What if it is 2 sine 2 theta cos 2 theta on RHS? This is very important discussion. I hope every one of you are focusing on this. So please observe, this is the 2 theta on RHS. This is the 2 theta on RHS. What will be the left hand side? So right, just think over here, if a theta is there on RHS, then you will observe the double the angle on LHS. If it is 2 theta, what is its double? So its double on LHS is obviously sine of, is it 4 theta? This is the thing that you have to observe very carefully here. So here it is a sine of 4 theta. So this is 4 times. This is 2 sine 2 theta cos 2 theta. We can express it as sine of 4 theta. So this is the replacement for 2 sine 2 theta cos 2 theta as sine of 4 theta, and rest of the thing as it is, which is cos of 4 theta into cos of 8 theta. So right, okay, so further, are you observing step by step we are reducing this term? So this next 4 you can split it as 2 into 2, and keeping the rest of the thing as it is, 2 sine 4 theta cos 4 theta into cos of 8 theta. Now please observe this thing. This is also a double angle formula for sine, which is as 2 sine 4 theta into cos of 4 theta. So see, try to observe. So I am trying to write the same double angle formula. Only thing is, over here it is 2 sine 4 theta into cos of 4 theta. So please observe it carefully. If it is a theta on RHS, it becomes double on LHS. So if it is 2 theta on RHS, then it becomes a 4 theta. So right, just this is on the basis of observation of the double angle formula for sine. Then what is your conclusion? If it is a 4 theta, what will be the left hand side? So obviously you have to double that angle. Since it is a 4 theta, its double is sine of 8 theta. So right, so this will be the replacement for this 2 sine of 4 theta cos of 4 theta on the basis of double angle formulae. So here I am continuing this problem. So this 2 I am keeping as it is. Then replacement for 2 sine 4 theta cos 4 theta is sine of 8 theta, and this last cos 8 theta as it is. Very interesting problem. Now the last one is also a double angle formula. If you are observing, this is 2 sine of 8 theta into cos of 8 theta. If you follow the same previous structure, whatever is the angle on LHS, it becomes double in case of double angle formula. So right, so this is 8 theta. What will be the left hand side of this double angle? So obviously sine of 16 theta. So right, so which is equal to the right hand side of this problem. If you observe, so here we can mention this as equal to the right hand side. So I hope you got this very interesting problem. So gradually we reduced the term by term this structure, and we got our final answer. Okay, the next formula which is important for the simplification is, we have to prove that cos 2 theta divided by 1 minus sine 2 theta is 1 plus tan theta divided by 1 minus tan theta. This is the thing that you have to prove. Or here, let's start with the left hand side. And if you observe this numerator, which is a double angle formula for cos, which is a cos 2 theta. Let's apply a formula for cos 2 theta. There are actually 4 formulas for the cos 2 theta, out of which I am using the first one, that is cos square theta minus sine square theta. So if you observe, friends, for the cos 2 theta, we have total 4 results. So if you remember this entire list of the formulae, so here, so if you observe the formula for cos 2 theta, this is the first one, this is the second, this is the third, and this one is 4. So there are total 4 formulas for the cos 2 theta, and as per this problem is concerned, I am using the first one in the list, cos 2 theta, as cos square theta minus sine square theta. So let's use this formula number 1, cos 2 theta as cos square theta minus sin square theta. Okay, then is it possible to replace this 1 as cos square theta plus sin square theta? Yes, it is possible, because cos square theta plus sin square theta is 1. And here I am using a sin 2 theta formula, which is 2 sin theta into cos theta. So right, so this is the formula for, so here I am mentioning it properly. In a numerator, formula for cos 2 theta is cos square theta minus sin square theta. This is in the denominator. So observe it carefully. It's all about applying a double angle formula. So in numerator, this case is actually a square minus b square. So right, what is a square minus b square? A square minus b square is a plus b, a minus b. So let's express this cos square theta minus sin square theta as cos theta plus sin theta and cos theta minus sin theta. So right, so this is for the numerator. Okay, so in numerator I applied this simple a square minus b square. So a square minus b square is a plus b, a minus b. So cos square theta minus sin square theta is cos theta plus sin theta. So this you can compare with a plus b and a minus b split up. So right, so this is almost like applying a square minus b square, a plus b, a minus b. Okay, the next thing is, the real interesting part lies in the denominator. So this is a square, this is b square minus 2ab. So friends, this is expansion of a minus b bracket square. So right, if you observe the denominator is actually an expansion of a minus b bracket square. So it's almost like a cos theta minus sin theta overall bracket square. So right, this is very little bit tricky problem, but observe it very carefully. And in the next step, if you observe this cos theta minus sin theta and this cos theta minus sin theta, these are the two similar terms out of which one get cancels. If one get cancels, then there will be only one power left. So what is left in the numerator is cos theta plus sin theta, and one cos theta minus sin theta and one cos theta minus sin theta from the numerator denominator cancels. So what is left is only one cos theta minus sin theta. Okay, so we reached up to this step. After simplification, in the next step I will suggest divide by cos theta throughout. The next hint is divide each and every term by cos theta. So let's observe, what if you divide by cos theta to this term? So this becomes 1. So right, what if you divide this term by cos theta? So it becomes tan theta. So right, the next thing is, what if you divide here by cos theta? It becomes 1. And the last step, if you divide here by cos theta, it becomes tan theta. And this one was the requirement of the problem, which is equal to RHS. This last step, please observe, we divided each and every term by cos theta, or if you want, I can write down a detailed step for you. Divide each and every term by cos theta in the numerator, as well as, this is very important step. So here I am dividing both numerator and denominator by cos theta. So if you divide each and every term, so what is the hint here? The hint is divide by cos theta throughout, to the numerator as well as denominator. And this cos theta cancels, leads to this 1. Sin theta by cos theta leads to this tan theta. Cos theta cancels, leads to this 1. And sin theta by cos theta is tan theta, which is equal to the right hand side of the problem. So right, okay, so hope every one of you are getting this problem on sin 2 theta, so cos 2 theta or tan 2 theta. These are all examples for double angle formulae, and these are all simplification based problems, and definitely you will face this kind of problems in calculus. So I hope every one of you will observe it very carefully. So these are very, very important things, and you will face this kind of structures for the simplifications in calculus, like in limits, in derivative, in integration or differential equation in your next here. So right, so therefore you must observe all these double angle formulas, then prepare its list very carefully, and if you want your trigonometry to be a strong, make sure that you apply these all formulas for the simplification. So means facing the number of problems is a trick in trigonometry, then and then only you will get accustomed with this simplification problems. Okay, so let's try to cover one more problem on this double angle formula. So this is sine of 3x divided by cos x in the denominator, plus this is cos 3x in the numerator, and I am giving here sin x in the denominator. What you have to prove here is this is equal to twice of cot 2x. So friends, I am starting with the left hand side, and let's cross multiply these structures. So this is sine of 3x into sin x, plus let's multiply cos x over here. So this is cos of 3x into cos x. This is entirely divided by multiplication of these two terms, which is nothing but cos x into sin x, or we can say sin x into cos x. For your sake of understanding, I am writing this term first and this term as a second. I will tell you the reason behind it, but let's write cos 3x into cos x as a first, and sin of 3x into sin x as a second. The reason is quite simple. We have formula for this kind of structure. In the denominator, I will suggest, so let's keep this thing in a bracket. In the denominator, I will suggest let's divide by 2 and multiply by 2. I will tell you the reason behind it. Okay, the first thing is why we consider this as a first term and this one as a second term. The reason is a compound angle formula. If you assume this 3x as a and x as a b, assuming 3x as a and x as a b. So friends, try to read this formula. It's like a cos a, this is like a cos a cos b plus sin a sin b. So it's a compound angle formula. So I am talking about this very important formula, cos a cos b plus sin a sin b. So and this formula is cos a minus b. If you remember, this is called compound angle formula, and as far as numerator is concerned, this is the compound formula that you have to apply. And here in the denominator, it's a simple double angle formula. 2 sin theta cos theta is sin 2 theta. So here I am applying these two formulas, compound angle formula in numerator and double angle formula in denominator. Okay, so please observe, this is cos a cos b plus sin a sin b. It becomes cos a minus b, that is 3x minus x, and this is like a minus b. So right, I am talking about this term. It's a cos a minus b. And what about denominator? 2 sin theta cos theta, using this formula, is sin 2 theta. So in the denominator it is sin 2x. So further, cos 3x minus x is cos 2x in the numerator and sin 2x in the denominator. You know that cos by sin is cot. So final answer is cot 2x. This is equal to RHS, which one was the requirement of the problem. But we missed this 2 somewhere here in this initial step. So right, so here I am mentioning into 2. So if you observe this 2, we adjusted over here with this 2. So let's multiply everywhere by 2. So final answer is 2 cot 2x, and hence we got this exact structure equal to RHS. So friends, I am requesting every one of you, solving a double angle structures is little bit tricky and somewhat lengthy also, but trigonometry itself requires two things. One, your job is to observe these double angle formulas very carefully. So always remember, there are two things or two tricks that you have to apply in trigonometry if you really want to be a good in trigonometry. The first, every time observe the formulas very carefully, observe their structures very carefully. And the second trick is, or second suggestion is, try to apply this double angle or triple angle or all trigonometric formulas to the maximum number of problems. Then and then only you will be comfortable with solving this kind of problems. So hope you will practice on your own also. So please try to apply these double angle formulas for few examples, and you will be get comfortable with this double angle formula. So here I am ending this lecture on double angle formula. So we covered few problems on this. In my next session we will cover few objectives on this, and even in next lecture we will see how to solve few problems on half angle formula. Even we will try to cover triple angle formulas in the next session. Till then, goodbye and take care.